So, without further ado, I will hand you over now to Simon Sturgis for the opening address. Simon is the specialist when it comes to embodied carbon in the built environment. He's recently been appointed Special Advisor to the Environmental Audit Select Committee. He advises the UK government departments, the UK GBC, the EU Commission, Construction Industry Council, as well as commercial clients such as British Land, Schroders and Google. Simon wrote the book that has become the industry standard, Targeting Zero Embodied and Whole Life Carbon Explained. He's also written official policy for the RICS, the RIBA and the GLA's new Car London plan. We're delighted to welcome him today to open our 5th climate emergency debate, Costing the Earth. Over to Simon.
Thank you, Andy. Right, I'll just take possession of the screen. Good. That I'm hoping you can all see that. Where I want to start is with the climate emergency. And I suppose really what this is, I'm suggesting this is what we all know, this is an existential threat to humanity. And I've aligned it or compared it to World War II, if you like, which was the last existential threat to humanity. And the manifestation of both is destruction of human life as well as property. And indeed, on the right there, you can see fires in California last year. But I would also equate it to construction, because if you think of the volume of construction and the impact of carbon emissions, that really these two things, and it's probably arguably a controversial observation, but really these things are not so far apart. And if you think I'm exaggerating, look at the global construction to 2060, one new Greater London every 7 weeks. I mean, that is a phenomenal amount of construction. And the impact of that globally on the climate is phenomenal. And the interesting thing is, of course, is that if you look at the sort of the people who are responsible, the countries that are most responsible for resource use, on the left there you've got the number of planets, number of Earths required per capita to achieve the kind of consumption, and on the right you've got carbon emissions. You'll see the same basic culprits in both cases. And in the UK, what we're trying to do is achieve net zero by 2050, which was passed by the Theresa May government. And then you've got 78% reductions passed by the Johnson government by 2035, which are significant asks. And if you look at, of course, what has generated that, that's been generated by Paris 2015, the COP21, and of course that's fed into the Climate Change Committee, net zero by 2050, and then the UK government's 78% reduction by 2035. So you have that, if you like, the kind of current policy concern and so on. So getting to zero, how do we get to zero? And I thought I would just explain this for those of you I'm sure may well be familiar with this, but I thought I would just show you in terms of the modular approach. So on the left there, top left, module A, upfront emissions in the green box, which are the product stage and construction stage emissions. Then you've got in use stage, which are the module B emissions, which include the repair, replacement, and refurbishment, all material related. Then in blue, you've got the energy use, operational energy use, and operational water use. And those together with the pink, all of those represent in-use emissions. So then you've got the end-of-life stage, reuse, recovery, and recycling. So all of those ones together represent embodied emissions, the A, B, and C, but only part of the B, because that bit of B, the B6 and B7, represent operational emissions. But if you add all of those together, excluding D, so A, B, and C all together represent whole life carbon. And to achieve net zero, you have to achieve the maximum CO2 reductions through good design and so on, plus any residual offsets. So that would give you a net zero position. And how do we actually get to that? Well, I'm showing a few things here, which the starting point is retrofit. Both of these building schemes here are retrofits. The one on the right, the one on the left is a Victorian warehouse, very clearly, which has been retrofitted. The one on the right is a retrofit of an existing city building, and the retrofit is saving 58,000 tons of CO2 compared to a new build version. But also in terms of there's materials. What are the better materials? On the left there, you've got the Google building showing a cross section through it, which is a mixture of CLT floors alternating with concrete, with steel framing and so on. And the cladding on the outside is a mixture of timber, aluminium and glass. And on the right there, you've got another office building up in Norwich, the Enterprise Centre, which has, amongst other things, it has thatch cladding. Well, you may think that's a bit crazy, but actually thatch lasts about the same amount of time as a double glazed unit, about 40 years. So it is not that strange to want to do these things. Also, the construction stage, there's the relationship between new and recycled material. New aluminium is essentially, if you're going to anodize, because you get a consistent substrate. If you're going to use recycled aluminium, then you can powder coat, which of course gives you more flexibility. So simple choices of coating can make a big difference in terms of what you're choosing. This is demonstrating, this is the use stage, which is really all about durability and adaptability. And the office building on the left there, you've got a very long life brick facade with double glazed units set into it, each of which can be changed to suit. The facade on the right is 3 layers of glass, a unitized system. And the reason it's a 3-layer system is because, of course, it's the air conditioning would be very high demand if it was just a single double glazed unit. So you've got a great deal of embodied energy locked up in a facade like a fully glazed facade, and that is not helpful at all, of course, and it's actually very inflexible. You've also got energy efficiency, which I'm sure we're mostly familiar with, and things like fabric first and the louvers to protect the facades. So there is a whole range of things that we can do to improve the performance of buildings. And the end of life stage is interesting because, of course, if you're demolishing, then of course typically it all goes to waste, and waste is also tends to be a much lower level of activity. For example, the waste goes to road fill and so on. But if you can actually rebuild the building, now this scheme here on the right is a project by Segro, which we in fact moved from one site in Slough, where it was going to be just demolished. We actually just had it dismantled, moved to a new site and rebuilt. And that saved a lot of money, it saved a lot of carbon, and relatively few things had to be replaced. The roof membrane, the foundations had to be replaced, but fundamentally all of that is effectively second-hand material. So it shows that it can be done. But of course, that building wasn't designed to do that. Had it been designed to do that, we would have achieved greater benefits in terms of cost and carbon. And in terms of cost, there is this perception that low carbon is an expensive activity. This is the Google building, which is under construction in King's Cross in London. And we were looking at the tender packages from the perspective of carbon as opposed to perspective of financial cost. And what we found was that, and the one here you're looking at is the lowest tender cost, which happened to be the same tender package as the lowest carbon cost. And so we found a direct correlation across certainly about 95% of the tenders across this overall tender. So there's a direct correlation we found between low cost and low carbon. And it is if we look on the left here, you've got a column which represents the sort of total package of energy and material, the new office building, the emissions over about 60 years. So this is showing kind of the build-up of that. And I would suggest, and it's certainly my experience, that using current technology and current supply chains and so on, it is certainly possible to get 20–30% reductions, which are cost neutral. And certainly with the developers that I've been working with who will not spend extra money, this is the kind of thing that can be done. So we can achieve, we have out there ready to achieve reductions, I believe, of 20–30% without having to spend additional money. When you get to the next step down, you're trying to push the boundaries a bit more, there's a bit more innovation required. And the next step down is obviously a much higher level of innovation. And finally, it's whatever's residual would be treated as an offset. So I think there's plenty of scope to act right now in order to meet those 78% reduction, emissions reduction by 2035. That can, we just need to be a bit more imaginative of what we do. So I thought I'd just finish with this, which is really that if you look at design progress, you look at the camera on the left, 1955 through 1970 in the middle to 2020 on the right. That's the sort of level of innovation. And it's worth considering the fact that the camera on the right, 2020, has more computing power than the whole of Europe did in 1955. I can't remember where I got that bit of information, but that I believe to be correct. You compare that with architectural innovation. London office building in 1955 on the left, and then in the middle, 1970, and on the right, 2020. And the differences are single glazed, double glazed, triple glazed. And the last two, the two in the middle, the one in the middle and the right, also have air conditioning. So we need to do a lot more. We need to think a lot more. And I would argue that to some extent that these buildings are now obsolete and certainly an obsolete typology, but we are still building them. Globally, we're still building them, but we need to think differently. We need to come up with new and different typologies to answer the problems of the climate crisis. And I suppose my final question is, what are they going to look like? We've already have some hints and things, but I think most of these don't go necessarily far enough. And there's going to be a lot more innovation needed in order to sort out the problems of the climate crisis so far as architecture is concerned. Thank you very much.